Thanks for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Luxman L-400 Integrated Amplifier. Luxman sold these between 1982 to 1985 at a cost of $330, which would be about $950 today. It was rated at 55 watts per channel into 8 ohms at 0.02% THD or better. This was sent to me by a member of an audio group that I belong to. Let's just call him Charles. And he had a complaint that one of the channels decreased in volume after it had been on a while. Unfortunately, after many hours of testing, I was unable to duplicate the problem. However, I did touch up many solder joints that seemed suspect that could have led to that. And I did set the idle currents for both channels, which were off a bit. And there was a burned out lamp. The DAD aux lamp was burned out and I replaced that. Here's a closer view of the Luxman L-400 Integrated Amplifier. And starting over here on the right, we have our volume control, which I should point out does not have detents. Our balance control is right here. Here is our function selector, and we can select between either a tuner, a DAD auxiliary, or a phono input. Now, the choice of moving magnet or moving coil phono inputs is done with this little push button here. And if we go over one more clockwise, we have a 15 Hz subsonic filter over here that can be selected as well. Whatever is selected over here, the appropriate lamp lights up over here. It has two tape monitor circuits, and they're selected over in with these switches. We have our loudness push button there. We have a stereo mono switch there. We have a 7 kilohertz high cut filter there, a 70 hertz low cut filter there, and here is our tone defeat switch right here. If we press the tone defeat switch in, we can use our bass and treble controls, treble control here, bass control here. It has the ability to control 2 sets of speakers, which is done right here. We have a 1/4 inch headphone jack, and our power on-off switch is right here. This obviously is the rear of the Luxman L-400 Integrated Amplifier. Starting off on the right, we have an unswitched AC outlet, and next to it is a switched AC outlet. We have upgraded speaker terminals here. Charles had purchased this with the upgraded speaker terminals already installed. They are very nice, 3-way banana binding posts, I call them, and are gold plated and a very welcome addition to this unit. We also have our tape monitor for number 2 here, tape monitor stuff for number 1 there. Here is our tuner input, auxiliary DAD input, and phono input here, and the phono ground connection there. Here is an inside view of the Luxman L-400 Integrated Amplifier, just to kind of give you an idea of the technology that was used back in 82 to 85. Nothing overly special. We do have our 2 idle adjust pots for the bias currents, which would be this guy right here, and there's another one over here, and there are associated test points right here, and right here, and then over here. And you set it for 15 millivolts plus or minus 5. We also have 2 capacitors for the power supply. They are 10,000 microfarad at 50 volt units, and the output transistors, there's 1 PNP and 1 NPN for each channel, and they are under the heatsink here. And here are just some of the controls and switches of the L-400. Here we have the Luxman L-400 putting out 5 watts into 8 ohms. The volume control is set to give 29 dB of gain, and you can see that our SNRs are right around 80. Our THD is at least better than 0.004%, and the THD plus noise is around minus 80 dB. So things are looking really good, and we've only got about a minus 13.1 dBV going in at 1 kilohertz. So now we're going to check out the frequency response. Here we have the frequency response of the L-400, and this is with it putting out 5 watts into 8 ohms, and I have been using the DAD/auxiliary input for these measurements, and you can tell that the frequency response looks really good. The channel balance looks great. Now this is with the tone bypass in effect, so it's bypassing the bass and treble controls, and you can tell we're down maybe 0.3 of a dB at the low end of the frequency band and only down maybe 1/10 of a dB at the high end of the band. I will point out that I had to tweak the balance control just a slight amount to get the two channels to line up, but they are pretty darn close. So right now we're looking at the frequency response of the Luxman L-400 with it putting out 5 watts into 8 ohms, and we're using the auxiliary DAD input, and the tone controls are bypassed right now. I'm going to take the tone bypass off, which means it's going to run through the bass and the treble controls, which are set flat. And so let's see what happens. So ideally you would want the frequency response to remain unchanged when you go through the tone controls. However, that's not the case, but still they are looking really good. So the channels are balanced to probably within 0.3 of a dB, and overall the frequency response is still flat to within maybe +1 minus 0.4 dB, so that looks pretty good. Once again, we're looking at the frequency response from 20 Hertz to 20 kilohertz, and I've expanded the vertical axis a bit so that we can see what happens when I put on the loudness. So we're switching it on now, and it looks like it's boosting the low frequencies by about 4.6, 4.8 dB, and it normalizes down about 2 kilohertz. So that is what happens when you press the loudness on button. Right now we're still looking at the frequency response, and I want to show what happens when I switch in the 7 kilohertz high cut filter. And you can see that it starts attenuating a bit before 7 kilohertz, but it's down about 7 dB at 20 kilohertz when that's switched on. And the last little filter that I'm going to show is the 70 Hertz low cut filter, and I will switch that in now. And you can see it drops at about 7 dB or so at 20 Hertz, and it's pretty well normal by about 250 Hertz. Here is the multi-tone test results of the L-400, and basically I would say that it's better than minus 80 dB, which would be about 15 bits of distortion-free range, so that's pretty decent. The L-400 had a specification of 55 watts into 8 ohms at 0.02% THD, and with the A weighting applied, it said that the SNR should be 107 dB or better. Well, we're at about 95, 96 dB, so we're not quite meeting the SNR requirement. The right channel's THD is meeting the 0.02% or better requirement. The left channel 0.06%. I'm not going to cry over that. Now we do see that the THD plus noise for the left channel is about 25, 26 dB worse than the right channel, and that is due to this third harmonic of the left channel being so high. Now if I go ahead and cut the left channel, you can see that the right channel is much better, and that is where the difference is. I don't really know what's causing that, but I'm not really that concerned about it with this 40-year-old amplifier, and we are pushing it at its limit. Here is a plot showing the output impedance of the L-400, and if I used the left channel at 1 kilohertz's value, let's say that's 0.32, if we divide 8 by that, we get a damping factor of about 25. So the right channel will be a bit better. There is no specification for the damping factor, but 25 is fairly decent. Right now I have the L-400 running into 4 ohm loads, and I kind of just wanted to see how it did into 4 ohm loads because there is no specification for it running into 4 ohm loads. One would think it would be double the 8 ohm rating, which would be around 100 watts into 4 ohms if you look at that, but I don't think we're going to get anywhere near that. Right now we're at about close to 39 watts, let's call it, and we're at 0.2% THD for the left channel and 0.02% for the right channel. I'm going to bump up the power just a little bit more. We're at 43 watts or so, and the THD for the left channel is getting worse. Let's bump up a little bit more. We're still at less than 0.2% THD for the left channel. Let's go up a little bit more. So here's 50 watts, and you can see this kind of the increased level of the harmonics. We're at about almost 1% for the right channel and 0.2 for the left channel. So I'm going to say the maximum that this amp would run into 4 ohms would be about 55 watts, or preferably less than that. These plots show the THD versus frequency for a couple different output power levels, and that's into 8 ohms. And if you remember that the THD spec was better than 0.02%, and that would be this line right here. So basically most of the output power levels, it does a real good job over frequency. At the lower end of the band, let's say below 100 hertz, we do get as bad as maybe 0.03%, still pretty darn good. And for the right channel at 10 watts, we get as high as about 0.05%, and then it gets better. So overall, this nearly 40-year-old integrated amplifier is doing a pretty good job with its THD. This plot shows the crosstalk or isolation between the left and right channels. In this case, I'm using the DAD auxiliary input. And I have a signal applied to the left channel, and the right channel is terminated into a short. And what we're seeing is that we have anywhere from down here, we've got, maybe minus 55 dB of isolation. Worst case, over at the high end of the band, we've got also maybe minus 50 dB of isolation between the two channels. And it gets at 1 kilohertz, I would say it's probably minus 75 dB of isolation. This plot shows the isolation between the tuner input and the DAD auxiliary input. In this case, I have a 0 dBV signal applied to the tuner input. The auxiliary DAD input is what is being selected. However, those inputs are terminated into a short. What you are seeing is the leakage from the tuner input onto the DAD auxiliary input, as seen at the output. And in this case, the output has 8 ohm loads attached, and the volume control is set for 29 dB of gain. So that being said, the worst case isolations would be about, we'll call it minus 50 dB, maybe a little bit more than that at the high end of the band, and it gets better than 60 dB, 70 dB at the low end of the band. Here we are looking at the noise of the L-400. In this case, we have the volume control set for 29 dB of gain. We're looking at the DAD/auxiliary input, and both those inputs are terminated into a short, and the loads are 8 ohm loads. And you can see that we're at least better than minus 80 dBV. And this up here would be our microvolts level, and that's showing about 425 microvolts. Here we are looking at the THD SNR at 1 kilohertz of the moving magnet phono stage. This is measured at the tape monitor 1 output, and you can see that our SNR is about 72 dB, and we're 0.001% and some change. THD, which is really good. The signal to noise ratio on the spec for A weighting with a 5 millivolt signal, which is the minus 46 dBV, should be 90 dB for a moving magnet, and we're nowhere near that, probably because of these power supply bars right here. But still, this is a fairly low THD for most phono stages, and you can see phono stage has about 39 dB of gain. Here we have the frequency response of the phono input with the moving magnet position selected, and the specification is plus or minus 0.5 dB. So we're pretty much there. We've got maybe 0.6 of a dB over here at the high end of the band, and then down here we're down maybe 0.3 of a dB. The channels are matched to within 0.3 of a dB. So overall, it looks pretty good. It is measured at the tape monitor 1 output. For my listening test, I paired the L-400 with my Wilson Watt 3 Puppy 2 loudspeakers. And those are basically I'll call them a 6 ohm speaker. If I average the impedance across the band, they do dip as low as 4 ohms towards the lower part of the frequency band, but for the most part I'd call them a 6 ohm speaker. at least from the data that I measured. And I was able to hit as much as 91 dB SPLs on some tracks, and I don't think the volume control was more than about 18, about this position here, maybe a little bit before the 12 o'clock position. I never thought the amplifier got warm up here, more than warm, maybe in the mid to upper 90 degrees F from what I measured. And it never seemed stressed. I thought it played everything just fine. For most of the listening, I had the tone bypass on. There were a few times where I did press in the loudness control to get some extra bass out. Not that the track I was listening to needed it, but I wanted to just see how it did, and it did really good. I was really impressed with some of that low-level bass that I was getting out of the Wilson Luxman combination. I terminated the inputs with shorts and moved the volume up to about halfway and listened to the tweeter mid-range area of the Wilsons, and really only heard the smallest amount of hiss, just really minuscule. So that's pretty good. And this integrated amplifier, I thought, just did a really good job. My only nitpick on it would be that it doesn't have a pre-out main in jack, but other than that, this is a very nice unit if you can find one. I did not listen to the phono input stage. It's something I typically don't do. But other than that, I thought it did a good job of meeting its specifications. And if you were at a yard sale or you wanted to find a nice vintage integrated amp that's going to sound good, I think this would definitely be one that I would search out and probably can pick up at a reasonable price if you're lucky. Anyway, that's kind of my take on the Luxman L-400, and I would like to hear your comments as always. And if you have not subscribed, that would be a nice thing to do. And if you like this video, please click the thumbs up. And once again, until next time, have a great day or night.